Hello 108 students, Mr. McCue back here with you, working on section 10.4. Going to take on page 4 here, see if we can get through a couple special properties we're going to cover here for this section. I have a comment up at the beginning of my notes that says, remember, exponents and logarithms are inverse functions. We can prove two special properties based on that: when the base is greater than 0 and the base cannot equal 1. We're going to talk about special property A, first one here. And we have something a little weird looking, a little strange. You've got the base raised to with an exponent that's got the log of the base, that's a b right here, with the result x. And this strange looking form, when it's all said and done, will simplify to whatever that result is, that's the output. And a way to prove that here is to take an example of, here's 2 as your base, raised to the log of base 2, result x, or excuse me, result a, 8. And the shortcut answer is simply take the result, drop it in there, and you're going to be done. However, why is that true? If you take log 2 result a and ask yourself 2 raised to what exponent equals 8, the answer is 3, and you can replace all this with 3. Now you've got base 2 raised to the third, and that is 8. Okay, so that's a proof. These are kind of specialized. When I remember these, you start to see patterns, start to see the base and the base 2 with a log. You see these patterns, you simply take the result and bring it outside and you're done with them. Another one here for special property B is to consider the case of, what if you've got a log base result has the same base raised to the exponent x, and kind of like the similar rules we just worked with there, the simplified answer is just going to be take the exponent, bring it out all by itself, and you're done. An example of that to work with is log base 2 result, which has 2 raised to the exponent of 8. Answer is going to be 8, but let's see if we can prove this to ourselves. So I come back and I look and I go 2 raised to the 8th can be evaluated at 256. So now you've got log 2 result 256. And then you say yourself 2 raised to what exponent equals 256? Answer is 8. 2 to the 8th, which is 256. And there's your result. Your 8 comes in there, and you save yourself a whole lot of work by learning the shortcuts there. Okay, so they got kind of those special rules here, A and B. You get a couple problems here where maybe you can work on them. Example 4A. Again, I kind of keep repeating myself, but I see log base 5 result 5 raised to the 4. I see the connection of the base and the base. Take the exponent, bring it out, and you're done. Okay, there's not a whole lot of work to do them. It's just recognizing the patterns and taking the exponent. Over here, this problem I like explaining my way. If you find this in the book, I don't know why the book jumps through hoops to explain this. They make a big deal out of this, but this is nothing more than, don't forget, a log is a way to express an exponent. And it says base 3 raised to what exponent, and that's what you're trying to find, equals the result 9. And when you do that in your head, you say 3 squared is 9, and there's your answer. Make them easy. Don't make them hard. Next one, 4C. Here we go. We've got, looks like this is special property A. 4 raised to the exponent, and these kind of catch you because you see the log up in the exponent. Log base 4, I see the same number there. Result 10. Just drop the result down, and that's all you have to do. Okay, now what I've got here in the bottom of the page here is I try to squeeze in a brief summary. What you need to do is spend some time, write up some reference cards, work on getting your mind comfortable with looking at these I'm not going to review them here again. You could see the product rule, quotient rule, power rule, special rules A and B. And while there's a lot of letters, you see these. If you practice saying B for base, X for the numerator, Y for the denominator, when you see the subtraction, just as an example, you're talking about the quotient rule. And going through the homework, it'll help you get comfortable with these. Try to match the patterns and you should be in pretty good shape. Okay, hey, we finished up page 4. We're going to go ahead and go to the last page here, 5 of this section, so I'll see you there in a minute. Bye.